Okay, question 4. So we're asked to write down the centre and radii of these circles. So CRE, so I've just started with the equation on top because we're given that. So we're trying to find C and R from the equation. I would do CRE if I was trying to find the equation from C and R. So yeah, just make sure you don't mix these up. So the first one's dead easy. We're just changing the sign. So we're going to have -5 and +6. And this equation is written equals r squared. Okay, so this is equal r squared. So I've got r squared is 9. So r is √9, which is just 3. So nice, easy start. Now this is a slightly more complicated equation. I've tried to catch you out as well because there's a term missing. That really should say something y. It doesn't. I'm just going to write 0y in there. Yeah, I've missed out that term to try and make it a wee bit confusing for you. So just watch out for that, which means the centre, we half these terms and divide by 2. So half of -6, that'd be -3, change the sign would be 3. And then the 0, half of 0, just going to be 0, change the sign, doesn't really matter. So the centre there, 3, 0. Very easy to make a mistake with that one. So, watch out. It's not this, you'd be very tempted to just go half them and change the sign, but there's 0y in there. In the same way that if this just said y squared, you would know that it's a 0 for that, or if they said x squared. Okay. The radius, that's going to be the square root of our g squared plus f squared, take away c. So g is just half, so that's -3 squared. Our f in this case would be 0, and take away c means I'm going to be taking away -16, so I'm going to add 16 onto there. Okay. See, I think when I do this, I always just think really you're changing the sign. Whatever's here, you're changing the sign for that. That's how I remember it. But anyway, so we're doing the square root of 9 plus 16. Oh, very nice. So the square root of 25. So the radius is 5. Fantastic. So four nice marks. 1, 2, 3, 4 for just understanding your equation of the circle. Okay. Now the next bit. This is where we're getting into our classic circle question where it's about visualization. Okay, so I'm just going to scroll down a little bit and I'm going to draw these circles out. So C1 and C2. Now they've asked us to prove that they do not intersect. So if they don't intersect, it'll look something like this. So what's the radius of this one? This one here, C1, is 3, and our radius here is 5. So what we should find then is that this distance here, if they don't meet, this distance, let's call it AB, has to be greater than 8. If it equaled 8, then they'd be touching once. If it was less than 8, then they'd be touching twice because they'd overlap. So we're hoping that this distance is greater than 8. So let's do a little diagram then. I'll call that C1. And just C2. I probably should put that inside the circle. So C1 to C2, and I always draw it like this at a slope, just to make my sketch better. So there's C1, and C2 is up here at 3, 0. Okay, so there's C1, there's C2, and this is line AB. So line AB, I can figure out the length of that by using Pythagoras. So if we have a look, in the x direction, I've gone from -5 to 3, so I've gone along 8. This has gone from 6 to 0, so it's gone 6. Now, the signs here don't matter. If you're looking at working out the centres and things, you would have to, check your signs are going in the right direction, but this doesn't really matter. So I've got 8 and 6. So AB squared, I'll put it, I'll just put B here just so when people look at this, they know that it's part B. Yeah. There we go. So part B. So AB squared is going to be equal to 8 squared plus 6 squared. So it's going to be 64 plus 36, which is 100. So that means that AB is √100, which is 10. So I would then say, well, AB is equal to 10, which is greater than 8, and therefore they do not touch. And a little sketch there just kind of, again, shows a marker, you understand what's going on. Okay, so I've called that point. I've called it AB because that's what I usually do in the textbooks, but technically that's then A and B. But yeah, so visualizing that is really important, and doing some Pythagoras comes up an awful lot in these questions as well. So if you're not using Pythagoras, you probably missed something, and understanding the equations with a couple of points there as well. So I do quite like the circle questions. Sometimes they make you think a little bit, but ultimately it does boil down to CRE, center and radius, and then doing some kind of sketch. And that sketch, a lot of the time, will involve a wee bit of Pythagoras. Okay, so yeah, hope that's helpful.